whatever the values were given, 3 by 2 into 100 when we worked out, we got it as 150. Like that, 10 divided by 8 into 100 if we work out, we get 125. 5 divided by 4 into 100, if we work it out, we'll get 125. So, 150 plus 125 plus 125, if you take, the total is equal to 400. That 400 we are calculating the average. So 400 divided by 3, it is 133.33. Now, when we want to calculate the chain base index number, then what we are doing, 100 is equal to 100, 133.33 is equal to how much? That is 133.33 into 100 divided by 100. So you will get the same as 133.33 as your chain base index. Now coming to the 2014, when we want to calculate the linked relatives, what we did, 4 divided by 3 into 100. 4 divided by 3 into 100, which is equal to 133.33. 12 divided by 10 into 100, so it is 120. 8 divided by 5 into 100 is 160. So 133.33 plus 120 plus 160, which is equal to 413.33. Divided by 3, you will get 137.78. So 137.78 into 133.33 divided by 100, if you work it out, you will get the chain base index number. 2015 also we have to work it out in the same manner. 5 divided by 4 into 100. 15 divided by 12 into 100. 10 divided by 8 into 100. So you are getting 125 for the 3 groups. So it total is equal to 375 divided by 3. That means average is 125. So 125 into 183.70 divided by 100, which gives you 229.62. In the last year also, we have to work out in the same manner. 6 by 5 into 100, 18 by 15 into 100, 12 divided by 10 into 100. So you're getting the totals is equal to 120. So all 3 groups put together, it is 360. 360 divided by 3, which is equal to 120. So 229.62 into 120 divided by 100, it is 275.55. This is how a chain base index, if it is to be calculated in the group manner. Individually, if it is given also, we have worked out. I have shown you how it is to be worked out. And individual, the group wise, if it is given also, need to be worked out like this. Now here also we have used the link relatives method. And the link relatives method we have used and we worked out. This is one way of working out. And yesterday, you have asked me about the theory part as well as the problem part relating to the link relatives. So let me show that also. Now, coming to the theory part, if you take it to the account, this is what the theory relating to the link relatives. The formulas were given, the link relative for the quarter. So whatever the quarter which you are supposed to calculate, that is the current quarter divided by the previous quarter into 100. For example, if you are calculating for the months, the value of February divided by the value of Jan into 100. In the same manner, if you want to calculate for March, it is value for March divided by the February into 100. That is how a link relative is supposed to be calculated. Now, when we want to calculate the average of those link relatives, so what you're doing, whatever each quarter, you are calculating the total divided by the number of the months which you are taking into the account. Then you will be able to get the average of the link relatives. Now coming to the, you want to calculate the chain relative for any quarter. In such cases, the link relative of that quarter divided, you have to link relative of that quarter multiplied with chain relative of the previous quarter divided by the 100. This is a formula which you have to use and you have to calculate for link relatives. So the link relatives problem also was given here. Now this is under the seasonal index. I don't know, you told me the seasonal index, you have only simple average method. but the link relative method supposed to be worked out under the seasonal index, then this is a question which is given. Calculate the seasonal index by the method of link relatives for the following data. He gave you 4 quarters data, and there are 7 years of data is given. So 2009, 10, 11, 12, 13, 14, and 15, 7 years data, and each year you have 4 quarters. So he has given the data. Now computation of seasonal indices which has been done. See, the first quarter doesn't have the previously whatever the value. That's the reason why we have taken it as a nil. But from second quarter, you are supposed to calculate. That is 258 divided by 283 into 100. If you work it out, you are getting 91.17. Can you work out once? 258 divided by 283 into 100. See whether you are getting that 91.17 or not. Please work out. 258 divided by 283 into 100. Are you working? Hello?
Hello, ma'am.
258 divided by 283 into 100.
91.16, madam.
Wow. So 166 you are getting. That's the reason why he has rounded off to 91.17. Could you see this value?
Yes, ma'am.
Like that, every quarter it can be worked out. 244 divided by 258 into 100. Please calculate. 244 into 100 divided by 258.
94.57.
So here it was there. See, 94.57. Could you see? The next 260 divided by 244 into 100. 260 divided by 244 into 100.
106.55, ma'am.
Right. So this is how. This is not from your textbook, ma. Yasmin, sorry, this is not from your textbook or whatever the material, instruction material you have. I have taken this from my textbook. This textbook is relating to business statistics. Kalyani publishes S.L. Agrawal, so that you can easily understand the values. Right? So here, Nana, the next if you take into the account, 210 divided by 260 into 100 work out. 210 divided by 260 into 100. 210 divided by 260 into 100.
80.76.
Okay, 80.76. See, the workings are being given here.
Okay.
Nana, I know from your text or your syllabus, you have only simple average method. That is very easy, very simple. The other methods are also there. One is link relative method, the moving average method, okay, ratio to trend method. So some problems relating to that also I have sent to the one of your batchmate, so that she will put it in the group. Now, if you know these, it is better. We don't know what will be given in the examination. Who is the examiner? How he will set? We don't know, right? So if in case any one of the problem, if it is given, you are capable of doing that. You can make an attempt and you can do it. That's the reason why I'm giving you the measurement of seasonal variations methods also. I'm giving you only one method was stated according to your syllabus. The other methods are also there. Whether it is stated in it or not, I'm giving you those information so that you will be able to know. If it is not coming in your question, it's well and good. Nana, always remember, if you're reading more than what is required, is always a beneficial that you will have a knowledge. Over and above syllabus is always is a knowledge for you, and in future for higher studies, even if it comes also, you can able to, you are capable of doing these things, right? Is it okay now? Because yesterday someone asked me about the link relatives, the method, the problem also. That's the reason why I'm showing this. Shall I move on to the next chapter, that is probability?
Yes, ma'am.
Yes. Then it depends if you want to learn more, because already now it is so vast. The syllabus itself is so vast for you in your as per the syllabus which I've seen. Then a correlation, regression, index numbers, time series, probability and probability theory distributions you have. So there are 5 units, 5 blocks in that, and each block you may have 2 or 3 units, right? So the now itself you have a very vast syllabus. So better if you know it, that would be better. Okay. My intention is to give you full information relating to the subject. Right. Now this is how you're supposed to work out. The continuation also, let me show you, and we'll switch on to the next. See, this is how the problem will be continued. So it is the totals, average, chain relatives, adjusted chain relatives, and seasonal indices. This is how it is to be worked out. So anyway, because it is not there in your syllabus, I'm not going further. But if you know, if you can have this information with you, probably it will be helpful. Okay, so shall we start with the probability chapter? Shall I start? The probability, that is the 4th unit.
Yes, ma'am.
Yeah, I'm switching off to the next is the probability. Ma, you know what is probability? What do you mean by probability? Probability here, it is a concept. Okay, it is in general, probability means a likelihood of an occurrence. That means any happening of an event. So the possibility of occurrence of an event is called as a probability. Okay. Now, we always think that probability means 50-50 chances. So that's the reason why usually we will denote the probability either in the form of a ratio, or it may be in a fraction, or it can be in percentages. So it can be denoted in any of the way. So what is the chance of happening an event, not happening an event? That is called as a probability. Now, usually the theory of probability has an origin in the games of chance. So the gambling theory we have, based on that, we have a games theory and the gambling theory. Based on that, the probability, the theory of probability has been introduced. Okay, Mr. Galileo, an Italian mathematician, who was the first man to attempt a quantitative measure of probability. Now, always remember, here the probability is also useful for us in solving the problems relating to the games, relating to the events, relating to the business related problems also. That is the reason why a probability is also need to be studied. Now, before to study a probability, we need to know how to, like, there are certain symbols. Those symbols are very, very important. So let me show you that symbol. You need to tell me what is that symbol stands for. Now, we say, what is this symbol stands for? Belongs to. This symbol stands for belongs to. If you write like this, it is does not belongs to. Now, what does the symbol stands for? This is pi or a null set. So null set will be denoted as like this. And we have union. Usually we write it as A union B. This is intersection, A intersection B, right? So A union B, A intersection B, and we have subset, superset. Like this, we have so many things which need to be known under your probability also, right? Now coming to the certain concepts which we need to know. What are those concepts? The first concept, they say random experiment. Random experiment means an experiment in an action or an operation which can produce any result or outcome. So if you're tossing a coin, that is an experiment. When you are experimenting one thing, you know very well either a head or a tail you will be able to get. Now this is fourth chapter, probability chapter. Under the fourth block, you have one unit called the theory related to the probability, the concepts of probability. There you have to take into the account. The next we need to take into the account, the another one is random event. An event is random. An event is random if chance factors alone determine its outcome. So whatever the chance of the factors which alone determines its outcome, then it is called as a random event. Now, mutually exclusive event. Two or more events are said to be mutually exclusive if the occurrence of one of them is a single trial, precludes or excludes the occurrence of all other. So when you are happening one event, automatically the other event supposed to be excluded. So that's the reason why it is called as a mutually exclusive events. Equally likely events, all possible outcomes of an experiment are said to be equally likely, because when you're tossing a coin, you know very well that you may get a head or a tail. So both, any one can be equally likely you can get. So that's the reason why we don't know whether you'll get a chance of head or a chance of tail. So, but both are equally likely events can happen. That is the reason why it is called as equally likely events. Now coming to the exhaustive events here is n possible outcomes. Whatever the outcomes, like tossing a coin, you have possible outcomes are two. One is head, one is tail. So these are two outcomes which you can expect. A dice, if you throw, there are 6 outcomes you have. So total 6 outcomes can be stated as an exhaustive events. Now you have a complementary events also. Complementary events are like the favorable events in case of an experiment, and the events which doesn't happen, that also a complementary event. Like we always denote it as A dash or A to the power of U. So these are, or A dash, you can say like this, A dash, A bar. So those are being stated as a complementary events. The next, we also say an independent events and a dependent events. When two events are being said to take place, both are independent in occurrence, then it is called as independent event. Dependent event is because of one take place. That's the reason why it is called as a dependent event. Now, favorable and unfavorable cases. Favorable is, now when you say, when you're tossing a coin, head is a favorable, then it is a favorable case. And tail is unfavorable. So tail, you have both favorable as well as unfavorable cases. Now, coming to the approaches to probability. We have 4 approaches. One is classical approach. The another one is relatively frequent approach, the subjective approach, and axiomatic approach. These are the 4 approaches we have under the probability. Now coming to the classical approach, The classical probability is also called as a mathematical or the prior probability measurement. It had a beginning with games of chance, and the formula to use under the classical probability, number of favorable cases divided by the exhaustive number of cases, or the total number of equally likely cases, which is nothing but the probability. Always we will denote it as probability of A is equal to M divided by N. M is the favorable chances and N is the total number of events. So, or cases which is to be taken. This is how usually a formula which is applied under the classical approach. And this is also known as a mathematical probability. This is also known as the prior probability. Okay, determined prior to the occurrence of the event. You know very well when you are tossing a coin, you know very well that head or a tail. So you can expect which one can be your outcome. So expectation before doing an event or an experiment, that is called as a classical probability. The next approach we have is relatively frequency approach. This is a formula under the classical probability approach. This is approaches to probability. Approaches to probability. Under that, first one is classical probability. There we have this formula to be applied. And what is probability? That means well in advance, whatever may be the occurrence that is being stated before happening of an event, that is called as classical approach of probability. The second approach we have a relatively frequency approach. The relatively frequency approach is also called a statistical frequency approach. So, which is also called as an empirical or a posterior probability or a statistical reference frequency approach. So here, what they say is, it is also called as a statistical probability. It is based on a relative frequency of occurrence. It is also called empirical probability. It is based on experiment and observation and also based on past experience and records. We have past experience and records. Based on that, we could able to judge what could be your event result, that outcome. So that's the reason why we call it as, we will call it as a posterior probability. They may ask you in this chapter, they may ask you, what are the approaches of probability? State briefly about the approaches of probability. You can expect for a short note or you can expect for a theory question, which is an essay question. So in both these sections, you can have such kind of questions. They may ask you the definitions of event, happening of an event, the success of an event, the exhaustive event, mutually exclusive event, independent event, dependent event. These are the definitions which you can expect. So they may ask you define this, or they may ask you about the approaches to probability. So two approaches which we have discussed. The next we have to discuss regarding to the subjective approach of probability. The subjective approach of probability is also called as a personalistic approach. The personalistic approach here is, we will have an intuition or a conviction stating that what could be the outcome of an event which can occur. See, out of our intention or out of our intuition, we may judge this will be our result. That happens. That is called as a subjective approach of probability. So this is the personalistic approach. That means it always based on your experience, your personal experience relating to your event. Maybe you have a past experience. That's the reason why you could able to judge what could be your result. That is the reason why it is called a subjective approach of probability. The next we have axiomatic approach to probability. The axiomatic approach of probability, this is introduced by a Russian mathematician in 1930. Okay, and he wrote it in the Foundations of Probability, which is published in 1933. And he has given you three axioms or the three rules. The three rules are one. The first rule is your probability of A, the probability of A is equal to greater than or equal to 0. That means your values, whatever the values which you have calculated, it will be more than 0. It is equal to more than 0 or it is equal to 0, but it will never be in a negative value. So it is a non-negative, axiom of non-negative. This is the first rule need to be noted. The second is the probability of sample space is equal to 1. So always they say the entire sample space is always equal to 1. And the third rule is they say that probability of A union B is equal to probability of A plus probability of B. So this is what we are supposed to take these three rules into the account. So based on these three rules, we are supposed to work out the probabilities. So this is what we have. The next coming to the rules, the probability rules for addition and multiplication. The probability rules for addition and multiplication is, like, let us say the first, the addition theorem, which we will take into the account. Under the addition theorem, we have probability of A union B is equal to probability of A plus probability of B. Okay. Now, here he says this is relating to the independent events. When it is independent events, this is the formula which we are supposed to use. And we have a dependent events. Under the additional rule, we have a dependent event. Under the dependent event, the rule will be the probability of A or B, which is equal to probability of A plus probability of B minus probability of A, B. Probability of A, B. So the dependent event should be taken like this and independent event should be taken like that in the additional theorem. Now let us take into the account the multiplication theorem. The multiplication theorem. So under the multiplication theorem, both independent and dependent events. If it is a dependent event, so we will take into the account probability of A and B is equal to probability of A into probability of B by A. Probability of B by A. Now, and independent event, if we take into the account, This is under the dependent event and independent event. 1 minute. In the independent event, you have probability independent event. You have probability of A and B is equal to probability of A into probability of B. So this is an independent event, that is a dependent event under the multiplication theorem. Now we have permutations and combinations also. Under that, we have to follow the rules. Shall I rub this one? These are the formulas to be remembered. Shall I rub this one? Okay.
Yes, ma'am.
Yeah. Now, combinations NCR. NCR. This you have to take it as N by N minus R factorial into R factorial. That means, like, let us say this can be written as now 5C2. That means you will be writing it as 5 factorial divided by 5 minus 2 factorial and 2 factorial. 5 factorial can be written as 5 into 4 into 3 into 2 into 1 divided by 5 minus 2 is 3 factorial. That is 3 into 2 into 1. 2 factorial is 2 into 1. So that means this up to 3 factorial and this 3 factorial get cancelled. And 2 into 1, that means here 2 2s are 4, which is equal to 10. The coefficient we can able to calculate by using NCR. This is the combinations which we have to use and we have to work out like this. Followed? This formula is very, very important. Please note down. N factorial divided by N minus R factorial into R factorial. Hope if you have studied maths in your intermediate, probably the permutations and combinations you may be able to remember. Yes? Could you remember this? Fine. I'm going to the permutations. In the permutations, you'll write N factorial divided by how many times the R factorial is taken. So you are taking in this manner. This comes under your permutations. So this is a formula supposed to be used under the permutations. So let us work out the problems relating to the... Now, see, find the probability of drawing the red ball from a bag containing 10 yellow and 20 red balls. You have to take only one red ball. And how many you have? The total balls you have is 10 plus 20, 30. So it should be 30. C1 is in your denominator. And in the numerator, you have a red ball is to be calculated. The red ball, there are 20 red balls. So it is 20 C1. So which is equal to 20 by 30. 2 by 3. 2 by 3, what is the answer? What is the answer? 2 by 3. What is the answer? 2 by 3. Is it 0.67? Are you listening?
Yes, ma'am. 0.66.
So this is the answer. So what is the question? Question he says, find the probability of drawing a red ball from a bag containing 10 yellow and 20 red balls. So 10 yellow and 20 balls, that means the total is equal to 30. 30 C1. That means in the denominator you have total balls. None of page number. I don't have your material. I'm taking the textbook which I have at home. So those textbook only I'm discussing here. This is how a problem to be worked out. Now, coming to the next, now I'm giving you one more problem. Let us work out that. Please note down the question. What is the probability that an odd number appears in a single toss of a die? What is the probability that an odd number appears in a single toss of a die? So, single toss of a die, that means a dice has 6 sides, right? And he says that means 1, 2, 3, 4, 5, and 6. These are the sides. Now, what he says, an odd number appears. Odd number is 1 is an odd, 3 is an odd, and 5 is an odd. That means you have 3 sides divided by the total outcomes is 6. That is, it is 1 by 2. The probability that odd number appears in a single toss of a dice is equal to 1 by 2. Followed? Have you followed?
Yes, ma'am.
Right. The next, let us go to the next problem. A die is thrown, find the probability of getting an even number. Nana, a dice is containing 6, right? So it is 6 is your outcomes. And he says the probability of getting even number. He wants to get even number. Nana, even number is again 2, 4, and 6. Isn't it? 3 numbers you have. 3 divided by 6. Again it is 1 by 2. The next he says less than 4. You should get less than 4. Less than 4 means 1, 2, 3. No. There are again 3 numbers you have. 3 by 6, which is equal to 1 by 2 again. Right. More than 4 he says. The next question he says more than 4. More than 4 means, this is the third question. More than 4. That means you have only 5 and 6, no? More than 4, you have 5 and 6. That means only 2 numbers you have. 2 numbers means you have to take 2 divided by 6, which is 1 by 3. Which is 1 by 3. More than 4. Now, at least number 3. At least number 3, that means you need to have, here we need to work out this. The fourth question, he says, at least 3. That means you have to take 3, 4, 5, and 6. There are 4 you have. 4 numbers you have. That means 4 by 6, which is 2 by 3 is the answer. Followed? Are you following?
Yes, ma'am.
Yes, ma'am.
Yes. Now, let us take one more problem. Shall I rub it off this? Okay. Next problem we have. What is the chance that the sum 7 appears in a single throw of pair of dice? Nana, 2 dice, pair means 2 dice, no? The 2 dice which is equal to 6 plus 6. Or it is 6 into 6 will be your outcomes. 6 into 6 is 36 is your outcomes. And he says, the sum 7 appears in a single throw of a dice. That means 4 plus 3 is equal to 7. 5 plus 2 is equal to 7. 2 plus 5 is equal to 7. 3 plus 4 is equal to 7. Now 1 plus 6 is equal to 7. 1 plus 6 is equal to 7. 6 plus 1 is equal to 7. That means you have 6 outcomes. Agreed? 6 plus 1 is equal to 7. Have you agreed, girls? Yes? So that means you have, this is 1, 2, 3, 4, 5, and 6. You have 6 outcomes out of 36. So here we need to take into the account 6 divided by 36, which is 1 by 6. Your answer is equal to 1 by 6. Shall I repeat the question? What is the chance that the sum 7 appears in a single throw of a pair of dice? A pair of dice in a single throw. You can get, these are the outcomes, no? So you'll get 3 plus 4 is one outcome. 4 plus 3 is another outcome. 5 plus 2 is another outcome. 2 plus 5 is another outcome. 1 plus 6 is another outcome. 6 plus 1 is another outcome. That means there are 6 outcomes you have. That's the reason why we have taken 6 divided by 36. Okay? Is it okay? Followed? Understood? Okay. The next, we will work out one problem where in how many ways can a letter of word setter can be arranged? Now, he's asking us to, in how many ways? The word he gave us as SETTER. This is a word. How many times it can be arranged? Now, 1, 2, 3, 4, 5, 6. So it is 6 factorial divided by. Now, T is repeated twice. So it is 2 factorial. E is repeated twice. It's 2 factorial. S is repeated once. R is repeated once. Now, this is called permutation problem. In permutations, we have to use this formula that 6 factorial divided by 2 factorial, 2 factorial, 1 factorial, and 1 factorial. Because T is repeated twice, E is repeated twice, R is repeated once, S is repeated once. So now this is 6 into 5 into 4 into 3 into 2 into 1 divided by 2 into 1, 2 into 1 into 1 into 1. So this 2 into 1 and 2 into 1 get cancelled. Now 4 2s are 2 4s are. So 2 into 2 is 4. Now you have 6 5s are 30, 60, 60 into 3, 180 ways. So this is equal to 180 ways. This is your answer. So a permutation where a setter can be arranged like this. Followed? Are you following?
Yes, ma'am.
Hello?
Yes, ma'am.
Followed? Yes.
Yes.
Right. Now, next, we will work out one more problem. Ma, there is one more problem. Like In how many ways can 12 students of MCOM class be allotted to 3 tutorial groups of 2 factorial, 4 factorial, and 6 factorial respectively? I'm repeating once the problem. In how many ways can 12 students of MCOM class be allotted to 3 tutorial groups of 2 factorial, 4 and 6 respectively? This is also a permutation problem. So 12 factorial, 12 into 11 into 9, 10 into 10 into 9 into 8 into 7 into 6 into 5 into, so I can say up to 6 factorial because we have in the down as 6 factorial, right? Up to 6 factorial divided by 2 into 1 into 4 into 3 into 2 into 1 into 6 factorial. This 6 factorial, the 6 factorial get cancelled. Now 4 2s are 8 get cancelled. 2 5s are 10. 3 3s are 9. So now we have 12 into 11 into 5 into 3 into 7. Ma, work out and tell me. 12 into 11 into 5 into 3 into 7. What is the value?
7.
11 into 12 is 132 into 15 into 7. So 132 into 15 into 7.
13,861.
It is 13,860 ways. See, 12 MCOM students arranged in 3 groups. The 3 groups are 2, 4 and 6. So this is how you have arranged in 13,860 ways. So this is another problem which is permutations, which I mean to say. So permutations, we worked out 2 problems, right? Now, the next we will work out the another problem. Yes, here. Now, the probability that a student passes an economic test is 3 by 4. I'm working out the another one. See, probability of passing economic test is equal to 3 by 5. And in both economics and statistics, probability of passing in economics and statistics is equal to 2 by 5. And the probability of passing at least in one test is 4 by 5. So that means here probability of economics union statistics is equal to 4 by 5. Find the probability that he passes in statistics test. That means probability of economics union statistics is equal to probability of economics plus probability of statistics minus probability of economics intersection statistics. This is what we are supposed to calculate. So now, here we have to work out probability of 4 by 5 is equal to 3 by 5. Okay. And probability of statistics was not given. Minus 2 by 5 is given. So now we have to work out see, probability of S is equal to 4 by 5 minus 3 by 5 plus 2 by 5. 5 is common. 4 minus 3 plus 2, which is 6 minus 3. So 3 by 5 is the answer. The probability of statistics, passing in statistics is 3 by 5. So using the formula also, we can work out like this. So probability of statistics can be worked out using 3 by 6. So this is the formula which we have to take into the account. Now the probability of statistics is equal to 3 by 5. Okay. The next, now let us work out. Is it okay?
Yes, ma'am.
The question marks, Nana, you have a short and you also have a long, no? In both, you can expect the probability because fourth chapter, it is completely fourth chapter. In fourth chapter, you can expect theory as well as the problems, both in your short answers as well as in the long answers. So you can expect both. And now, let us work out one more problem. Yes, ma'am.
We can expect that theory also for probability.
Yes, theory also, because approaches to probability and the concepts, the events, all that. The definitions relating to independent event, dependent event, mutually exclusive event. Right? Now, let us work out another problem. Now, total number of tickets are 30. So, like, let us say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Now, he says total number of tickets are 30. What is the probability getting a total which is divisible by 2 or 3? Divisible by 2 is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. How many are getting? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So, which is divisible? Probability of 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You are getting 15 by 30, right? Okay. Which is divisible by 2. Now, which is divisible by 3? Probability of divisible by 3. That means 3, 6, 9, 12, then 15, then 18, 21, 24, then 24, 27, 27, and 30. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 by 30. Right? There is a repetitions, Dana. 2 or 3, you have a repetitions. Repetitions is, now 6 is repetition under 2 under 3 also. Right? And 12 is a repetition under 2 and 3 also. And 18 is repetition under 2 and 3. Okay. The next 24 is a repetition under 2 and 3. Right? So 30 is also repetition. So that means you have 1, 2, 3, 4, and 5. So 5 by 30 is also you have. So that means 15 plus 30 minus 5. That is
40.
40 by 30. 40 by 30. Followed? Are you following?
Yes, ma'am.
So now when we rub off this, so we have
1.3.
15 by 30 plus 10 by 30 minus 5 by 30. So 30 is common. Your 15 plus 10 minus 5, which is equal to 20 by 30, right? (25 minus 5). So 5.
0.6.
It is 25 minus 5 or it is
0.66.
0.67.
No. What is this is right, Nana? 10 you got. Divisible by 3 is 10. Divisible by 2 is 15. Please count again. What we have written is right.
24 by 30.
24 by 30.
24.83.
Is it 24 you'll get?
Yes, ma'am. 15 plus 10 minus 5 by 30.
15 plus 10 is 25 minus 5 is 20. No. Somewhere we went wrong. Again, you calculate and tell me, Nana. Let us see. Something is missing. Now, 2 divisible by 2 is from 1 to 30 is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The next 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, divisible by common, which is 1, then 2, then 3, 4, 4, this is 5. Right? So now we have 15 by 30 plus 10 by 30 and minus 5 by 30. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So, Nana, you will get 20 by 30, which is equal to 2 by 3, that is 0.67. This is the answer. Okay. Is it okay?
Yes, ma'am.
Right. Now, this is how the problems to be worked out under the probability. You go through the problems, theory as well as, so you can expect anything in your examination. With this, the 4th block is also completed. Tomorrow, we'll start with theoretical distributions. That is, we have a binomial distribution, Poisson distribution, and normal distribution. These are the 3 which we are supposed to complete in the 5th block. So with that, the total syllabus
Ma'am,
will
can
be...
you say the important questions for exam?
Yeah, tomorrow let me complete this and then I'll tell you what are important.
Okay, ma'am. Thank you so much.
Now, let me take the attendance and then we'll leave. Okay. Yeah. Thank you, Nana. We'll meet tomorrow.
Okay, ma'am.
Right. Thank you. So I'm leaving now. In the last classes, people used to come for 31 or 32, but now it is participants are only 12. Why it is less? Anyway, thank you. I'm leaving.